So, as you know that the meaning of this CFL is compact fluorescent lamp, and this CFL is very much similar to fluorescent lamp. Okay. In the last class, we have discussed about the fluorescent lamp. Okay, so you know the construction and the working principle of fluorescent lamp. The same, almost the same working principle is applicable in case of CFL. Okay. One more thing is that the efficiency of the CFL is far better than the fluorescent lamp. Okay. So we will discuss about the different aspects of CFL and fluorescent lamp, the comparison between these two electrical illumination items. Okay. Before that, let's have a look of the construction of this CFL. Okay. You can see this diagram. This is CFL. Okay. This one is the screw base. Here, this CFL will be fitted into the holder with the help of this screw. Okay, that is called addition screw base. Okay, the name of this screw may be different based on their pattern, their design. Okay, how the grip has been manufactured. Based on that, the name is varying from a different manufacturer point of view. So don't worry about that. This is the screw base. The second part is polycarbonate housing. Okay. This is polycarbonate housing. This is an empty space where some other parts of the CFL are fitted into this empty space. Okay. This polycarbonate housing. Basically, this work as a heat sink also. Okay. If the CFL will be heated when they switch on, then this portion will act little bit to release the heat also. Okay. So it is made up of polycarbonate material. Okay. So this one is polycarbonate housing. In this housing, in this particular area, the main component of this CFL is fitted into this. Okay. What is that main component? That is electronic blast. Okay. Electronic blast. फ्लोरोसेंट लैंप में भी हम लोगों ने देखा था एक इलेक्ट्रॉनिक ब्लास्ट, एक मैग्नेटिक ब्लास्ट था विद द हेल्प ऑफ द स्टार्टर. Okay, that combination work to start the tube light under the low voltage condition also, or for a smooth running of the fluorescent lamp we were using the magnetic blast and the starter combination. Okay. Now in this case, that complete setup has been transformed into the electronic components. Okay. So its name is electronic blast components. And since the electronics parts are small in size, electronic parts are small in size, so this complete blast component is compact, and that is why it is named as compact fluorescent lamp. Since the size of the fluorescent lamp has been reduced, it is compact in nature. Okay. Due to this blast, electronic blast component. Okay. You have seen in your households. Okay. That is not an issue. You are very much familiar. So this is the main component of CFL. Above that, a mounting plate is there. Okay. On the mounting plate, these electronic components are fitted in the bottom side of this mounting plate, and above that, some tube retention clips are there. Okay. These are just the clips to hold this glass discharge tube. Okay. This complete glass discharge tube is held on this mounting plate with the help of this tube retention clip. Okay. So this is the simple construction of CFL. Okay. So the main parts, you can say that this screw, polycarbonate housing, electronic blast, and this glass discharge tube. Okay. These are the main parts of this CFL. Another diagram is shown here. Okay. This, another view of the CFL, where additional one or two item you can see that starter is shown here, and the base pin which is at the outside to hold in the holder. Okay. Then a capacitor is also here. We have seen in case of the fluorescent lamp also, one capacitor we was using one capacitor. Okay. What was the purpose of that capacitor? To reduce the interference. Okay. So these are the components of CFL. As I told that its working principle is very much similar to fluorescent lamp. Okay. You can see here also the working principle. A CFL uses a vacuum pipe. Okay. CFL uses a vacuum pipe. This is the vacuum pipe, or you can say the glass tube. Okay. Which is principle wise same to fluorescent tube. So glass discharge tube or the vacuum pipe, whatever you call. Okay. These has two electrodes on both ends. Okay. You can see these two ends. On the both ends, there are electrodes. One is anode and another one is cathode. Okay. So when supply is given to this CFL, the temperature of the cathode electrode, that will start increasing, and it will increase around 900 degrees centigrade, and then generates a beam of electrons. Okay. When the supply will be given, then this electrode, cathode one, will generate a beam of electrons, and these electrons will flow inside this glass tube with the help of the potential difference which is created in between both the electrodes. Okay. We will give the supply. When the supply will reach to this electrode will start generating the beam of electrons, and that electrons will flow inside this tube due to the potential difference between the anode and cathode. Okay. You can see that the temperature which is around 900 degrees centigrade. Okay. So we are treated the electrode with barium. Okay. Some treatment is required to control this high much of heat. Okay. So we are treating the electrode with barium. So higher the energy which is generated, okay, or you can say the flow of electron, but higher the rate of the flow of electron, the higher energy will be generated. Okay. And that is directly proportional to the light. Okay. So when these electrons will accelerate inside this tube, then what will happen? Inside this tube, just like a fluorescent lamp, there is mercury and argon atoms. Okay. Mercury and argon atoms, these are present inside this glass tube. You can see this diagram also. Okay. So electrons will strike these mercury and the argon atoms. Okay. And the ultraviolet radiations will release. Okay. So there will be generation of ultraviolet radiation when the electrons will strike the mercury and the argon atoms inside this glass tube. Okay. If you remember that in case of the fluorescent lamp, there was a coating of phosphorus inside the glass tube. So when ultraviolet radiations strike the phosphorus coating, then light is produced. That was the case for fluorescent lamp. Similarly, in case of the CFL also, some coating inside the glass tube, there is some coating. Okay. So when these ultraviolet radiations strike that coating, okay, then the visible lights will appear. Okay. That coating is called luminophore. Okay. It is basically an atom or a functional group, okay, in a chemical compound that is responsible for its luminescent properties. What is the meaning of this luminescent properties? Means basically this is a material. Okay, this is a material chemical which is present inside this tube, and its function is to convert the ultraviolet radiation into the visible lights. Okay. Am I clear till now?
Yes, sir.
So working principle is almost the same as in case of the fluorescent tube. Okay. When we give the supply, then the electrodes will emit the electrons. It will strike the mercury and the argon atoms present inside the tube and generates the ultraviolet radiation. And when the ultraviolet radiation will strike the coating which is present in the inner side of the glass tube, then the ultraviolet radiations will be converted into the visual lights. Okay. That is the working principle of CFL. If you go further into the detail section of this complete process, okay, so we will see about the circuit of this CFL. Okay, how the electrons is able to generate the light. If you will see the circuit of CFL, that is the blast component. I'm talking about this one. Okay, this electronic blast component. Okay, what are the components available here? What are the electronic component available in this electronic blast circuit? Okay, that we will see. Main components. So we call it as a CFL PCB. We can call it as, okay, CFL PCB, or we can also call it as the blast component of CFL. So the main components is divided into two parts: blast and the glass filled tube. the purpose of the filtration of the current. Okay, and two switching transistors. Okay, these switching transistors basically they are IGBT types of transistor. Okay, so different components have been shown here in this diagram. Okay, you can see also the name has been given. Okay, what is this? F. This is chalk. Okay. Where is rectifier? This one is rectifier. Then the capacitor. This one is capacitor. Okay. What is this H? This portion. This is the feedback transformer. Okay. So different components have been shown here. You can see that number of electronic components we are using to generate light with the help of this CFL. Okay. So why we are using this rectifier, filter? Okay. Is there any purpose? Yes, there is a purpose. So what is happening when we are supplying the AC input to the CFL? Then first of all, that AC is filtered. Okay. Then we are sending that AC to bridge rectifier, and that bridge rectifier will convert the AC into DC. Okay, the AC input is converted into the DC with the help of bridge rectifier. After that, we are using a filter circuit. Okay, just to remove the ripples which is present in the converted DC power. Okay, then after filtration, that DC is converted into high frequency AC by using transistor. Okay, so we are using transistor here to convert DC into high frequency AC, and then that high frequency AC current is applied to the CFL tube. So basically what we are doing, from the input what we are giving here at the screw terminal, okay, that input terminal, that AC which is at 50 Hz is converted into high frequency AC current when it reaches to this point. Okay, when it reaches to this point. So before entering into the glass tube, high frequency AC current is available here. So 50 Hz AC is converted into high frequency AC current with the help of this electronic flash component. So first AC is converted into DC, and then that DC is filtered with the help of filter circuit, and then it is converted into reduce. Okay, so we need to convert into the high frequency, okay, in order to produce light. Okay, so that is the basic purpose for this conversion. So these are the processes which are being followed, okay, in CFL. So this is the basic technical parameters and the technical aspects of the CFL. Till now, if you have any question, then you may ask. Okay, otherwise I will proceed. You can see this one also, the different components. Okay, what are the different components for the sake of your clarity and knowledge? Okay. You can see in detail one by one the different components. That's why I mentioned here. That was my intention. Okay. So this block diagram shows the conversion of 230 volt 50 hertz AC input into this high frequency ACC. Okay. These are the steps. Okay. Now coming to the advantages and disadvantages of CFL. Okay. What are the advantages? It is energy efficient, obviously. It is saving energy. If you compare it with the incandescent bulb or the fluorescent tube, it has higher lifespan. If you compare it with the incandescent bulb, its lifespan is 5 to 15 times higher. Okay, so it will run for a longer period of time. It has lesser power rating. This is another advantage. The power rating is less. Okay. If you compare the illumination from the illumination point of view, okay, how much lumens is available by another advantage of CFL is a low life cycle cost. Low life cycle cost, it means the cost of if you purchase a incandescent bulb. Okay, so what is the price of that bulb? Around 15 rupees. Okay, but if you purchase a CFL, the price will be around 70, 80, 90. Okay, so if you compare the requirement, okay, you compare that how much electricity you are consuming or how much electricity you are saving, okay, compared to the overall its life. Okay, the life of incandescent bulb is less, but the life of CFL is more. So if you compare and calculate a ratio, you will find that it has low life cycle cost. That means initially the cost is high in case of the CFL, but if we talk about the life cycle, then the ratio is less in case of CFL. Okay. अगर एक CFL हमारा उसका लाइफ सपोज 4000 वर्किंग आवर है और एक इनकैंडेसेंट बल्ब का 1000 वर्किंग आवर है, सो ये जो रेशियो अगर निकालेंगे प्राइस और इसके लाइफ का, so that ratio is less in case of CFL. Okay, it means the initial cost is high, but it will go longer. Okay, that is the meaning of this low life cycle cost. So this advantage, it takes more time to start and the initial purchase cost is high. And like all other fluorescent lamp, the CFL contains the mercury, so its disposal is little bit an issue. Okay, so these are the disadvantages. So that was all about CFL. Okay, now coming to the next one, that is LED, light emitting diodes. Okay. So we are using LED bulbs very frequently in our day-to-day life. Okay. So the main part of this LED bulb is this light emitting diode, LED. Okay. It is just a small bulb, okay, which can be easily fit into an electrical circuit to produce light. Okay. In case of this LED bulb, there is no any filament. Okay. We have seen that there is filament in case of incandescent and the fluorescent lamp, but in LED there is no filament. Then the question will arise how it will emit light, how it will generate the light if there is no filament. So there is a diode. Okay, there is a diode which emit light. Okay, with the help of the diode, it is able to generate the light. And now another question will come, that how a diode can produce light. Am I clear?
Yes, sir.
Is the question is clear? Yes. So in case of the incandescent bulb and fluorescent tube, there is filament. With the help of the filament, we are able to generate the light. But in case of LED bulbs, there is no filament. Okay. Only diode is present, and that diode is generated. So with the help of that diode, we are able to generate the light. So let us see that how a diode is able to generate this light. Okay. I think you are very much familiar with this p-type n-type junctions. Okay, what is forbidden gap? Okay, you know about these things, no? You have already learned, I think in the first semester or second semester, okay, or in the physics also. ये सब पढ़ा हुआ है ना? You are very much familiar with this basic concepts of the semiconductor.
Yes, sir.
So this LED is nothing but a PN junction diode, okay, which emit light when an electric current passes through it in the forward direction. Okay? LED क्या है? एक PN junction diode है, और जब इससे एक इलेक्ट्रिक करंट हमारे पास करता है फॉरवर्ड डायरेक्शन में, तो वो लाइट एमिट करता है. डायोड हमारा क्या है? अगर उससे रिवर्स डायरेक्शन में करंट फ्लो करेंगे तो करंट फ्लो नहीं करेगा. So when the current will flow in the forward direction, this will emit light. How? In the LED, the recombination of the charge carrier take place. Okay, the recombination of the charge carrier, it take place in LED. Recombination क्या होता है? That the electron from the n side and the hole from the p sides, they are combined and give the energy in the form of heat and light. Okay. Normally the holes are present in this p type and the electrons are present in n type. So when we supply the current, okay, we are giving some basically some energy. Okay, then the electron will move from n type to p type and it will recombine. This recombination of this charge carrier take place. Okay, and during this process, the heat will release. Heat in the form of the light. This will release. Okay, and that is the process that a diode is able to produce the light. So for the manufacturing of LED, we are using gallium arsenide phosphide. Okay, we are using gallium arsenide phosphide for manufacturing of LED, and this will emit red or yellow color of light. Okay, if you use some other material in combination with this gallium arsenide phosphide, then some different color will also produce. Okay, so that's upon us that which color we want. But basically, we are using gallium arsenide phosphide for manufacturing of LED. Okay. This is the working of LED. This working is completely based on the quantum theory that you have learned in the physics. Okay. There is nothing new. What is this quantum theory? It states that when the energy of electron decreases from higher level to lower level, it emits energy in the form of photons. And the energy of photon is equal to the gap between the higher and the lower level. Okay. This is a simple quantum theory, and this working is based on completely on this quantum theory principle. Okay. We are familiar with this quantum theory. Okay, so I'm not going into so much detail. This is the screw, okay, screw base. Then this is a thermally conductive